Okay, so our conclusion for this trapezoid is that the area is I'm going to say average altitude times width, which is having to write it kind of small there because I didn't leave myself enough room. Okay, I didn't put the meters per second on the 3 and the 7, but I can factor out meters per second. And then when I multiply that, I'm sorry, these are meters per second. And when I multiply by 8 seconds, the second divides out, leaving you meters, right? Yeah. So usually, and for right now, I want you to write out the meters per second on each of these. I don't have room to do that because I didn't leave myself enough room. But I want you to do it, and I'll keep after you to do it when you write things down. Okay? Now, what are you going to do? That didn't make any sense, did it? What are you going to do to analyze the meaning of this? Well, (3 meters per second and 7 meters per second are velocities. And I'm just going to say that the velocity is changing linearly. And what do you think I mean by that? Velocity is changing linearly. It's an abbreviated statement. I'm going to make a more extensive statement, but it means that you have a straight line on your velocity versus time graph. Okay? So I'm going to conclude that the area is average velocity times your delta t, your time interval. And if you multiply your average velocity by your time interval, average velocity is average rate of change of position with respect to clock time, it turns out. Okay? Now we incubate that for a while, so if you don't totally understand that, the instant you hear it, you're going to have plenty of opportunity to let it incubate. Well, when I say plenty of opportunity, 6 days. And that should be long enough. Times your delta t, time interval, for how long that velocity's average velocity applies. And that's just an application of the rate of change definition. Okay? You get the displacement. Now, in another situation, this might be dollars per hour and this might be hours. Okay? So over the period of a year, you keep getting pay raises, so your pay kind of goes up and more or less uniformly. That would be nice, right?
Yeah.
Okay? Let's say from $30 an hour to $70 an hour. That'd be okay, wouldn't it?
Yeah.
You can handle that. Okay?
Yeah, I don't think you could ever get.
And by the time you're done with your education, you know, that's going to be perfectly realistic range of pay rates, we hope. And you multiply that by however many hours, you would get how much money you make, right? Okay, so this can model a variety of different things, and we want to look at some of the different things you can model this way because there are many, 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 and you've seen at least 4 examples in the problems that you've had. Okay? So you want to be able to think in terms of, if y means this and t means this, what does this area mean and what does this slope mean? Okay? Big deal.